All right, everybody. Thank you for coming by for our second panel of the show. Today, we're having a conversation around building science and sustainable engineering for your homes. We've got some guest speakers here. This is going to be a Q&A section where I'm the moderator. I'm going to be asking a bunch of questions of our panelists here, and then they're going to add to, share their own expertise. And hopefully it's very relevant to everybody out there that's building homes. And if you're not a builder, you live in a home or you're going to build a home, you'll probably find this quite relevant as well. So I'll quickly introduce myself, and then I'm going to allow each of the panelists to introduce themselves. My name is Richardson. I'm the CEO and founder of Deako. Deako makes modular smart light switches. It's a whole home smart lighting system, really around you realizing the energy saving benefits, the convenience, the security benefits that come with a lot of different types of smart home technology. It's specifically around smart lighting. Andy, would you like to introduce yourself? Andy's from Construction Instruction.
Yeah, thank you. My name's Andrew Oding. I'm from Construction Instruction out of Denver, Colorado. Some of you might have been out to our CI lab. We're a building science engineering firm that does testing of products, but our main clients are home builders. We work with about 175 home builders across the U.S. and up in Canada. And to be quite frank, we're also the team that when things go wrong in the homes that we all build and develop, we're the ones that get to go in and find out what's wrong and why. It's all about the science.
Yeah. All right, so you're the building science geek, specialist, expert, and you consult with builders to help them, get the most out of these programs. All right, Aaron, and yourself?
I'm Aaron Bailey, out of Dallas, Texas, Cambridge Homes. We do about 200 homes a year, all 100% Energy Star. Been doing building science for about 12 years now. It's been a long journey to get all of our homes Energy Star certified. A lot of trips out to Denver with construction instruction crews. A lot of time, a lot of effort, but it's the way of the future, and we're happy to be here.
Great. So, as a recap, you're a home builder in Texas, and you've been on this journey for quite a years, and you got a lot of battle scars and learnings that you're going to share with the group.
Yeah, you can look at me and see I have a lot of battle scars. No, yeah. So out of Dallas, regional builder, about 200 homes a year.
Great. And Nathan, introduce yourself.
Yeah, thanks, everybody. I'm Nathan Diehl, head of product design and customer support at Deako. So over the last 7 to 9 years, I've been helping revolutionize the world of lighting controls. And to me, the next phase is to elevate the smart home to be a comfortable home, a secure home, but also an efficient and healthy home. And there's a lot of innovation that we're working on in R&D behind the scenes to bring things about. But it's time to start stepping beyond lighting as Deako. And that's why we're hosting this panel today, is why we're here, is to start talking about what's next.
So these are some of the industry experts here talking about building energy efficient sustainability with your homes. I'm not an expert in this stuff. I hear things like Energy Star, net zero. It can be confusing. Help demystify that for me. Andy, you want to help us off?
Sure. So we'll start out. So here in the U.S., we have the International Energy Conservation Code. And right now, a lot of the states are moving towards the 2021. Some still are back on the 2012, 2015. Every 5 years, there's a little bit of a change. The efficiency goes up. Right now, that 2021, which I think about 20 states or more have adopted, is pretty close to this thing called Zero Energy Ready, which is a DOE program. So to a homeowner, what's a zero energy ready home? Quite frankly, folks, it's a home that Nathan and team would build that uses so little energy that if you wanted to actually offset all the energy you use, all you would need is some solar panels on the roof. So they reduce the load. It's a quiet, comfortable, efficient home. And now with a little generation, you can generate everything you use the course of the year. Energy Star is sort of a step-up program to Zero Energy Ready. Energy Star is always about 15 to 20% above the local IECC code. And you'll have Energy Star 3.2, 3.3. You'll have different programs relevant to different states. But I'll just simply say this, and I might get in trouble for this, so bear with me. As a home builder,
you're on video here. This is recorded. This is live. This is going out with
how many builders have you ever seen stand up, say, I build the building code. Isn't that a great? I mean, why? The building code is the minimum standard that we build to so we don't get in trouble with law enforcement. So builders that lean into actually building homes that work are going to lean into programs like Energy Star and Zero Energy Ready, not just because of the sustainability, but folks, these are homes that actually work at the end of the day. So, yeah.
But isn't the idea that if I just build to the minimum of the energy code, that's the cheapest possible way for me to build? Or can I actually, is it cheaper for me to actually build above the standard?
Well, depending on who you are, you can build above the standard, and with the right programs, with the Energy Star program, you get a 45L tax credit. That for myself in Texas, Climate Zone 2 and Climate Zone 3, it's actually cheaper to build it better with a program like that.
That's an interesting one. So when you say a zero energy ready home, let's take a Climate Zone 4, Climate Zone 5, Climate Zone 6, even Climate Zone 2. Most of the builders are going to find out that the 2021 IECC to move from there to zero energy ready is going to be less than the $5,000 tax credit, hands down, no problem. But I think the other part too is we often forget that the cost of a home to build isn't just the first cost that we pay for products to go into build. We need to build this thing called total cost. So as a home builder, we know that our total cost to build a home is your hard cost and your soft cost. And soft costs are things like warranty and callbacks and reputation. And we know that on average across the US home builders usually carry between $4,000 and $6,000 soft costs just to take care of warranty items.
But wait a sec. How can warranty calls change depending on me building a more sustainable, energy efficient home?
I think the biggest one lately is 310 commissioning and on HVAC. I know you're a subject matter expert on it, but we've introduced having 310 inspections on all of our HVAC equipment. And over the last 6 to 8 months, we've seen our warranty calls there in Texas down about 65%.
65% less warranty calls?
Yeah, so they did I think an exercise, right? 4,000 units, and of the 4,000 units that they tested, over 80% of the HVAC systems were installed wrong.
And we're finding that not just, everyone says, oh, it's heat pumps. It isn't just heat pumps, folks. We think that when we buy a new home, that a mechanical system, a furnace with the fans and everything gets tested before homeowners move in. It doesn't. It gets installed, it gets signed, and the home gets left. And how do we know if it doesn't work? The homeowner calls. So programs like Energy Star and Zero Energy really take the builder to the next level where they know when they turn that homeowner to the homeowner, this house is going to work. The other thing too, just anecdotally, we've heard from some of the large nationals here in the US that upon implementation of Energy Star, even the 50% better, that they've had upwards of an 85% reduction in comfort and indoor related calls on the warranty side. That's enough money on the table to actually make it cost effective.
Yeah, from a manufacturer's perspective, it really ups the ante on our responsibilities to educate the builder and participate in the ecosystem. I can't just ship a product and drop it and forget it off. I now have to figure out how to integrate it in, how to educate the energy rater, how to educate the commissioning agent to be able to deploy this product in a way that it's going to meet these standards so to actually be able to reduce those warranty claims and make the installation right. So it's a challenge that's kind of elicited to the manufacturers to produce a better product, which I find exciting because I think that's really why we're here, is to yield a better experience. It's a product that's going to make everybody have a healthier, happier home.
Aaron, do you have anything further to add?
No, I just think since we've implemented going 100% Energy Star and introducing the 310, we have a better roadmap of how our homes perform when we hand them over to the homeowner. So in the event there is a warranty callback or something like that, we're able to go back and look at the records of the home. We're able to look at the 310 commissioning, send the vendor out there. They can look at the static pressure was this. They know it's a fan issue, or it's able to dial in and actually, it reduces the call time, right?
So when you're trying to drive to these more energy efficient homes, what are some of the biggest challenges that you as a builder face?
For myself in Dallas, the biggest challenge obviously is going to be cost, right? So, I can build the greatest house in the world, but the buyer's got to pay for it, right? So for a high-end custom home, it's very easy to get to those numbers. It's very easy to install all the widgets and bells and whistles to get you to an energy performant home. But how do you scale that and get it down to a production style type home, right? And that's what takes all the times. And you think you get it dialed in, you flip one other switch here, and then you just screwed up what you did for the last 2 months, right? So there's a lot of time, a lot of effort, but the key component to that is partnering with a good energy rater.
What is an energy rater? Tell me a little bit about that process.
So every home builder, obviously, with your permitting process, the municipalities require you to have energy documents that are subject to that municipality, and you have to have a licensed rater to do your modeling for you. So that rater's job is to tell you, hey, with your specifications and with this plan, these are your numbers right here, and if that's up to your standard or that's what you're trying to perform to, that is kind of that's your eyes and ears to get to that energy level. However, if you don't have a good energy rater, I mean, you're only doing is what they're telling you to do. So it took us probably a year and a half to get with the right partner, get it dialed in where you have someone that you trust, and together you work together to flip these levers to get these houses to perform the way you want them.
So it's maybe even the difference between somebody helping you go through a checklist of items and somebody consulting with you, collaborating with you to make it happen.
That is correct. So if you just want to check the box and be a good enough builder and build a code, that's the route you go, right? But if you don't want to be mediocre and you want to make it happen and get a better performing homes, you have to get a better energy rater.
I think a lot of this starts with education. Understanding that there's these different building codes, different compliance bodies out there, but that's just like the end result of years and years of building science and data crunching and legislation to try to communicate that, to enforce that change. But you have to step back and be like, why the hell are we doing this stuff? And why does this work together? Or why is this making it better? Why is this making it worse? And I know for me on my journey, I had to start with I read the building code, I read IECC, I read Energy Star, and I felt dumber at the end of it because I'm like, I understand why any of it made any sense. So I had to get some education on the building science side to be like, oh, okay. But maybe Andy, you can help us a little bit. Like, yeah, what are the big things that matter in building science, and where do you start with that?
Well, I'll give you a big one, right? Aaron and team and many of you folks, you have the air tightness testing, right? To get your IECC compliance, your Energy Star. But I can tell you that 99% of the individuals at this convention this year that would call themselves high performance individuals, engineers, can't tell you why you blow or door test a home. They'll tell you it's because of energy. They'll tell you it's because it's low carbon, it's good quality. Here's the reality of it. 65 years ago, building scientists in Canada and the United States and Sweden discovered that air leakage is the second leading cause of making our attics and walls wet. And when stuff gets wet, it forms mold. It is second only to rainwater. And if you read your IECC and go to the appendix, which is the most interesting part of the code but non-enforceable, it'll tell you that the reason air barriers and air tightness are in the building codes is to limit the amount of interstitial condensation. So knowing that, how tight do you want your homes to be? Pretty darn tight. Rainwater leakage is at the top. Air leakage is next to make it wet. Dew point control is third. And the last one is vapor control. We spend a lot of time in building science world worrying about things having to dry, and it's true they do. But I'll tell you what, the key thing is, don't let the thing get wet in the first place, and that's where air tightness comes in. The flip side is with good air tightness, you now can right size some things in your homes.
Yeah, building building a really airtight home, that might feel stuffy, right?
Well, that's what some people say, but you ask any home builder how many holes do you want in your house, see what they tell you. You don't want any holes in your house, right? So, years ago, everyone always said a house needs to breathe, and that's the wrong answer. You need to have a 100% airtight house, and you need to control the fresh air that comes in and out of the house, similar to a mechanical lung. And then put on a MERV 13 filter, something like that, filtration. That's the way to go.
So what are some of these things that people are doing to help with that air circulation, ventilation?
Well, when you build it tight, you have to ventilate right. We've known it for 75 years. We keep saying it. You need it tight to keep the walls and the roofs dry. Once you make it tight, you need to ventilate it right. Our ventilation used to be in the IECC and the IRC windows. So here's an interesting one. Do people want more windows or less windows in homes these days? More.
Or
They want operable or fixed. They like operable. Do they open them? No. So the ventilation needs to be mechanical. So there you can do exhaust only. You put a fan on a house, you suck the air out, and you hope that fresh air comes in through the holes. Well, in an airtight home, you actually need, when the air goes out, you need air to come in. And that's why things like ERVs and HRVs are important. And when it brings in that air, right, it brings in air that's preconditioned.
well, wait, you use these terms ERV, HRV. What do these things mean?
So energy recovery ventilation device, you put it in the home, you put it on, there's lots of them out here. It brings fresh air into the home. The home smells fresh, and the homeowner can control the home now because you've built the home tight. So energy recovery ventilator. So the air brings fresh air from the outside. If you're in Texas, before it brings that air in, it's actually going to pre-cool it. It's going to pre-dehumidify it. And the air coming in, you may not even need an accessory dehumidification device. And in cold climates, it's going to preheat the air that's going to come in. It might be minus 20 outside. The air it brings in is already going to be all the way up to, I don't know, 60, 55 to 60, pre-warm it. And you get fresh air for about $50 US a year.
Sounds like a pretty good deal.
The way in which we communicate this to homeowners, though, is it needs to change a little bit. Like fresh air is something you really touched on, that I think it helps explain what an ERV system is. But the comfort that it gives you, the quality of breathing that it gives you inside the house, those are the things that the home buyers are looking for. They're like, I want my kids who have asthma to feel safe at night. I don't have to worry about that. I want to know that the damn fan isn't as noisy. And a lot of the solutions, when we look at code compliance, we're looking at just checking that box. We have to go beyond that and think about the comfort and convenience of the home. So, for example, Deako has a ventilation timer switch that helps you meet an exhaust-only strategy, but you don't want to just depend on that in one location. For example, if you put that in that bathroom downstairs and somebody closes that bathroom door and it defeats the whole system, well, you're going to end up with all of the problems and none of the benefits of it. Plus, it's going to be louder whenever it's in that single room. So you can make choices like deploying these systems throughout your house in a couple different rooms, provide some redundancy, and it allows you to operate a fan at a lower CFM, at a lower noise level to make it more comfortable, more usable, and a little bit easier from the homeowner too.
I think a lot of times people don't even really know that they have these problems. You know, they it's hard for them to even judge what is good air quality, bad air quality until, you know, is my home airtight until I get my energy bill, right?
Or you smell it.
Or you start to smell it, right?
Your nose is still your biggest guide. When it comes to indoor air quality, there's a lot of products out there that'll treat the air, filter the air, and do things. And you have to understand that one of the biggest important points about making any building have better indoor air quality is get rid of the air that's inside and bring in the air from outside. Believe it or not, that is one of the biggest single impacts. And so one of the biggest ways you can tell, even without fancy controls that have, tell you what the RHs or what the VOCs are, is you'll smell it. And we've had homeowners, right, will buy these Energy Star homes, net zero homes, and they're afraid to sell them because those homes, they knew what it was like to live in a home that smelled fresh. The odors were controlled. The kids were a little healthier. They breathe better at night. They didn't have the sleep apnea issue, but they're afraid to buy a home from another builder because they're not sure that's what it's going to be like in that house.
Yeah. So what you're saying is I could buy a home and have a great experience with it around lower energy bills, better quality, feel better. And you're kind of like tied to that builder with the next time you want to go buy your next home when you're upgrading.
Yeah, so we have that a lot where, homeowners will actually come back and ask, hey, what all did you actually do to this house or whatever? But yeah, I mean, we can build a sustainable house. We can make an Energy Star. As a builder, I know I'm building a better house and it's better than my competition. This is what we do. We have pride in what we do. But for the buyer's not buying that house because you tell them it's Energy Star. That buyer's buying the house for the indoor air quality, for the comfort, for the MERV 13 filter because their kids has allergies, right? And back to your comment about the bath fans. My wife was sitting here. She just walked away. But I don't know about you guys, but my wife and children never use the bath fans, right? So, with a tight house, with the less than one air change per hour house, you can be in an adjacent room, and if your teenage child is taking a shower, that relative humidity goes up to where it's pretty uncomfortable. So without proper ventilation, with an ERV or controlled bath fan or switch, you're going to feel that in a high performance home.
And the reality is a bunch of these times, it's hard to do it after the fact. It's way more affordable and appropriate to do it at the time of construction. And isn't that like one of the main reasons of why buy a new home instead of one of these old homes? It's just easier to do.
It is easier to do. I'm gonna let you answer that.
Yeah, I mean, it's very expensive to retrofit a house to today's Energy Star standards and today's building code standards. And I think it's actually going to be forced that way here soon, right? With November of next year. You could probably talk about that, but it's very difficult to retrofit an existing home to get the quality of indoor air control that we have, the ventilation, the mechanical ventilation, and the performance levels.
So it sounds like, in the last, you know, set of years, decade, 2 decades, there's been a bunch of innovation that's happened. What are some of the biggest bang for your buck things that you should spend as a builder?
Yeah, so number one, you got to get your air sealing down. So, what if you don't get your air sealing down, you've done missed the mark. So for us, the biggest bang for the buck, I think, was aero barrier. Once aero barrier came to the market and it was scaled for production type style homes, that makes it pretty easy for new construction. Once again, that's why you should go new construction, not remodel.
For those that don't know what aero barrier is, what is it?
I'll let the scientist explain it.
It's an aerosolized air sealant. They're under AeroSeal here, actually. So it aerosolizes a sealant into the air. The house is pressurized, and all the particulate finds the holes, and it seals the holes, and it makes the homes tight. So it gives the builder and the homeowner consistency and air tightness. You can then right size your mechanicals. The homeowner now can control their indoor environment, right? You can't control the sieve. It doesn't work, but it's tight so you can control it. The other one too, on top of air tightness, when it comes to high performance homes, things like that, you'll get into continuous insulation. So layers of insulation on the outside of the envelope. It's like wrapping that house in a blanket, a continuous layer. So you're not getting thermal bridging at every stud. And it actually helps. One of the things that helps is it actually helps keep the wood dry, which means there's less propensity for rot to occur in that structure. The other one, though, too, I'll just say is windows. Here's an interesting one. Aaron and team, we talked about this, is that the homes that are built today in the US have about 15 to 22% window to wall ratio. In other words, 15% of the walls are windows. In the 1980s, folks, it was 6%. What that means is if you find a window that has a really good R value, that window can actually add more thermal effectiveness to the entire house than putting 2 inches of R10 on the outside of the wall. It doesn't mean you won't do that, but what it means is our decision matrix now for high performance, maybe we should be looking at windows and then looking at continuous.
Sure. Very interesting.
To me, this has been exciting to watch the journey of the home builder. Like air tightness was obvious that was the place to start. And you as home builders are starting to adopt that, starting to build that in, taking the years to figure out how to build that into your house, which products to choose, how to actually execute on that. The trend that I think is upcoming and really exciting is the electrification, but it wasn't going to make an impact until the air sealing was done. But now that we're starting to, it's not a solved problem, but we know how to solve it. We know how to make homes airtight now. And the electrification is that's the next step. So all the appliances becoming electric, the availability of induction cooktops, hot water, heat pump, water heaters, all these devices are becoming more accessible and the systems are simpler to be able to install. So to me, that's the revolution that's been happening over the last 5 years. That's been exciting and setting us up for what's next after that.
Number? So here's an interesting number on that. Department of Energy has done some studies over the years. We as building science geeks do the number as well. Take a 2,500 square foot home built across climate zones 5, 6, maybe even 3 and 4. Under the 2021 IECC, the heating, cooling, ventilation, and domestic hot water, these are operational loads, things the builder has control over. Under the 2021 IECC, the total load of those things is only 50% of the total energy use in the house now. The other 15% is totally out of the builder's control. It's the occupant load. It's what does the occupant put in the home? Do they have a Bitcoin mining operation in the basement? Is he like the Oding residents? We built a net zero ready home. We were net zero ready until we put a hot tub in the backyard. So more and more electrification, the ability to control, like products like yours, you're going to see products here like Span and Savant and Schneider that give the ability to control these high performance homes. So start to address the occupant load, because that's where the builder really can't go. That's homeowner.
Yeah, I agree. So going to Energy Star and then net zero, that's basically the pinnacle as a home builder, that you're going to get this home across to the end user. At that point, it's habits. It's the homeowner's habits. You can no longer make this house any more efficient than what it is. It's up to the homeowners at that point. So how do they get to that point? And it's monitoring the electricity, right? Electricity usage with the Span panel apps. Siemens next to us has them.
That's the other way. They asked about new technology. So some of these, the Span panels, the Schneiders, the Savants, and so on. The beauty about this is we all have this angst in North America about, oh, electrification, what's going to happen to the grid, right? We're going to have electric vehicles, we're going to have heat pumps, and the grid's going to go down, and we're all going to be in the dark. And the reality is when you actually do the math, like the folks in Sweden, Finland, Canada, EU have done, is they have found out that, wait a minute, if you actually build homes that are airtight, well insulated with better windows, the peak load of those homes is actually diminished. And now when you add these accessory loads, those can be controlled by smart control systems like Span, using things like Deako and other things tied into it. And that's what's going to happen. And it also keeps us as a nation from having to size our electricity generation based on peaks. That's crazy. It's like trying to kill a mosquito with a shotgun.
I mean, I've even noticed, I live in Seattle, and so we don't have these huge temperature climate changes, but we've had 2 major storms in the last 4 months that took out electrical wires at my house, and I lost power for 5 days and 3 days, right? But because I've got solar, because I've got batteries in my home, we weren't affected as a family, right? Texas has got all sorts of problems, and it's not getting any better. So it's like, we have to start building this way.
Like, one of the things that on the outset, you look at this technology and you think if it's all additive, you're like, well, I'm going to spend $1,000 for this. I'm going to spend $10,000 for this, 500 for this. And what all the coalescence of building science and these technologies are allowing us to do is to right size our equipment. We're actually able to put smaller systems in place that are more efficient, and through more intelligent control of these things, to be able to have that energy efficient house that's not impacting the grid, that's comfortable, that's healthy, and that's safe. And to me, that's what we're on the precipice of, is actuating on that. If you look at the way that the code is written, the way that you rate and scale a house, is it's under idealistic conditions. We look at the floor plan, we look at the bedroom count, we look at the amount of glazing on the house, which direction the house is facing, which climate zone it's in. We take some averages of weather patterns over the historical time and say, well, we think it's going to be this. Well, so designed to this, but what we really don't know is under that 50% occupancy load, what's happening. And that's the next era, is building intelligent controls and systems into houses to adapt to those situations over time.
So Nathan, obviously this is a biased question here, right? But as we're driving down through better building science, the energy consumption is a lot more manageable. And as you said, the occupant load starts to become a key driving force. What are some of the things with the Deako system that can save that occupant impact? Because, is lighting a big portion of the energy load now in this profile for a home? Where does it rank in the big picture of things?
Yeah, well, let's get an independent answer on the science fact of that first, on the lighting load, but then I'll follow up after that. But
And we often say lighting because it's easy to say, and that's what it's plug loads. The lighting, we have LEDs, we have really cool things. And again, they don't use a whole lot of energy in the home. It's the plug stuff. It's the stuff that's plugged in. It's the non-fixed appliances, right? And we have lots of those in homes now. Computers and Xboxes. We have 4 kids in our home, and I couldn't believe what an Xbox actually pulls. Like, you can tell on the energy thing whether it's on, right? Heated fish tanks, things like that. So the ability to control through controls like this is really, really important.
Yeah, and our products can help you with that today. You obviously can lower the dim level of the house systematically to be able to reduce your impact without changing your experience inside your house. But what's next is introducing additional sensors and controls and intelligence into this product line. And that's what's going to allow us to really revolutionize it. So we talked about that, how the house was designed under that slice of time and code. Well, now we're going to be able to start doing intelligent things based upon occupancy inside of rooms, based upon the temperature, the humidity, the air quality inside of the rooms, making discrete choices for that room at a given period of time, opposed to at just the home level.
So you're kind of hinting at some of the things in the future. What what are some of the things that are coming down the pipe, guys, that you see are going to be like the next wave of innovation that it's maybe not in the code today, but it's going to be in the code?
So one of the things that the high performance builders that are doing Energy Star, as you're already, are starting to understand is when you do these efficiency things on homes, the mechanical heating and cooling loads drop by 40 to 50%, which means the size of the equipment not only can get small, it has to. We have a real issue, Achilles heel in North America right now here in the US, where we are oversizing our systems and the heat pumps and the furnaces are short cycling, which means the warranties start to fail on them.
What does short cycle mean?
Short cycling is when the furnace or the heat pump comes on and turns off because it runs at one stage. What we need small equipment that's right size that can run at continuous levels to meet part loads. So there's some cost savings there. But one of the things that we're seeing is that as the load in a home, a heating and cooling load starts to diminish, we can start to have opportunities to condition the spaces, not just through forced air, but with water. So things like radiant heating and radiant cooling are now possible in production scale housing that has low energy consumption. And when you use water to distribute energy through a home, it's phenomenal. The comfort levels change everything else. So you're going to see materials here, right? Aaron was talking about them, air to water heat pumps, not air to air, but air to water systems. You'll see systems where there's no refrigerant lines between the outdoor unit and the indoor unit. They're monoblock units because they're doing all the heating to clean the hot water outside, using the air to do it. And you're going to say, well, that's fine in a warm climate. We're doing this in Whitehorse. It was minus 54 last year. And it does the domestic hot water. It does the heating of coils in the floor. And it can also do radiant cooling in the walls.
Yeah, I think another item as well is the cold weather heat pumps that's really came on. So naturally, the heat pumps was mainly a southern climate, 2, 3, 4, maybe 5. But now they have the heat pumps so efficient that climate zone 6, 7, and 8. I mean, they work well.
So it's getting that heat pump to be able to work in cold climates.
Yeah, I think the technology with the heat pump. I even see dryers now. They have dryers here that are heat pump dryers. So you don't obviously we're going carbon free by 2050. So I mean traditional gas water heater, you're taking that flame, what's it, 3,200 degrees. You're trying to heat your water to 120. I mean, how efficient is that, right? So eventually they're going to get rid of all the gas in the homes. And Energy Star even has another program, Energy Star Next Gen. So it's all electrification.
And I think you got to be careful too. Like, it's not just about, not using gas in a home. There's going to be a need for natural gas. You take that molecule, you crack it, you make materials. We wrap spaceships, we go to Mars, we go to the moon. We can use it for other things. But to think that you have to burn it in a home today to raise your temperature this much is sort of like using a D8 Caterpillar to till your backyard garden, or using a chainsaw to cut through butter, right? So there's other places we can use it. The other thing too, though, to understand about heat pumps is one of the things in North America we're still trying to get our head wrapped around is there's energy in the air down to 0 degrees Kelvin. So go back to school. What is 0 degrees Kelvin? Anybody remember that? It's minus
It's like 237 or something like that.
37. It's the temperature in space. Anytime the temperature is above 0 degrees Kelvin, there's energy that we can access. That's innovation. That's cool. So.
Yeah, to me, these are all exciting things. And I think that we're going to see two things. I think we're going to start to see the maturation of these technologies get to the point that individually they'll have hit diminishing returns. So the only remedy after that is to look at the systems in aggregate and to be able to control them intelligently. So not only are these individual solutions for each of these, for heating, cooling, hot water, cold water, insulation, air tightness, air movement inside the house. Each of these systems are getting better and better and better, and they're gonna hit their wall. And now the next phase is like, how do we get them to work in concert together? With the advent of AI and the commodification and advancements in sensors that are becoming available, we're going to be able to unlock that next 10%, that next 15%, the next 20% of that experience. To me, that's what I'm most excited about, is to be able to affect the whole cohesive system together.
I think that's a really important point of thinking about how can we get this to work at scale for the average person, right? Something that just works. I don't need to think about what the steps that I have to do on a day-by-day basis to save energy or to get better air quality, right? It just needs to happen for me. I appreciate everybody's time here. Do you guys have anything else to add to this conversation that I couldn't prompt you with a question that you feel like the audience needs to learn the most?
I think one of the last things is accessibility. All this stuff is getting cheaper. The education on it's becoming more convenient. So it's no longer something exclusively for the custom home segment. I mean, Aaron really can prove this here.
Yeah, so before, Energy Star is usually just high performance custom homes, and it's easy because it's a cost plus, purchase. But now scaling it down, and with Energy Star homes, these homes are lasting longer. I mean, the average home used to last 50 years. Now with these high performance homes, this house will be around for 100 years. So I think the key to that is building houses that can grow with the end user, and that's why we implemented your switches, obviously. So I mean, it's just a dollar or two more per switch, and technically you're pre-wiring the whole house for future integration with smart home systems.
Andy, anything else to add?
I'm good. One thing we always like to remind folks is, as much as we love building science and as builders, high performance builders, we like to talk about dew point and carbon and everything else. When it comes to the homeowner just wants to know that what they're buying is better and that it's going to work better and they're going to be proud of it. It's going to make them happy and they can brag about it. So don't call ERVs, call them fresh air machines. Talk about the house being quiet. Talk about being better. As a home builder for years, we were building 1,500 units a year, and I got all my sales team. I had all the figures on energy savings for all the homes. They told me after a year, we never use it anymore. Homeowners really aren't concerned about the cost when it comes to high performance. They want to know what it does to them as a family. That's what you need to talk about. So the conversations on science that we have today, talk about it very differently when you talk to the homeowners.
Yeah, and I think that's an important point. How you make buying a home, it's the most expensive purchase anyone's ever going to make. And they're going to live in that. Most people are going to live in their home for at least 10 years, right? So it's you got to make it that emotional connection. So Andy, you've got a ton of information. How do people get a hold of you if they want to consult, use you as a consultant for their projects?
Thank you. No, our team at Construction Instruction, so you can Google it. We have a app both on Apple and on Android. It's one of the largest actually building science apps in North America, Construction Instruction. Download the app. We also have, what's really cool is Construction Instruction Live, which is where we met. So it's a training center in Denver, Colorado. We offer courses, 2-day intensive building science courses. They're hands-on. You don't just sit and listen. You're actually in building walls. You're testing them. You're making them wet. You're seeing if they actually work. So come join us, and we have a crew there that's glad to help you.
And Aaron, yourself, for those that might be wanting to talk to a builder, maybe even that's gone through this from your side of the world. Tell us about your company again.
Yeah, so we're Cambridge Homes. We're out of Dallas, Texas. I don't do social media. You can find me on LinkedIn, but I can say in the journey for us going from a code standard builder to getting to Energy Star, after finding the right energy provider, my first trip was to Denver. So I've been to every class that Justin and Andy has taught. I brought my team over there, and together, I mean, you need to have a good education program set up to get the buy-in to move to that level.
And Nathan?
Yeah. Well, you can start right here, talk to any of the salespeople here at the booth to learn a little bit more about the product, or you go to deako.com to learn a little bit more.
Right. Does anybody in the audience have any question for our esteemed guests over here? Any topic that we didn't touch on? All right. Well, thank you guys very much for spending the time with us this afternoon. I know that I learned a lot. Hopefully others did as well. Appreciate you all. Thank you very much.